Hello everyone, welcome to this asynchronous session. In this video, we will learn about problem solving with patterns. Let us start with this one. Predict the next term in the sequence. So how are we going to answer this problem? We have this given sequence 1, 4, 7, 10, 13, 16. What is the next term? So what do you think is the next term? So looking at the difference between two consecutive terms we have, so the difference between 1 and 4 is actually 3. And then we have between 4 and 7, it's also 3. Then 7 and 10, it's also 3. 10 and 13, we have 3. And 13 and 16, we have 3. So in here, we can actually recognize the pattern that to get the next term, we need to add the constant 3. That's what we call constant difference, usually denoted by letter D or variable D. So adding 3 to 16, we get the next term, which is 19. So the next term in this sequence is 19. How about this? What do you think is the next term in this sequence? We have negative 5, 0, 7, 16, 27. So using the same technique, getting the difference between two consecutive terms, we have between negative 5 and 0, the difference is actually 5. Between 0 and 7, we have 7 as the difference. Between 7 and 16, that's actually 9. And between 16 and 27, we have actually 11. So what have you noticed and those differences? You can see also another pattern, and these are actually odd numbers. We started with 5, then we have 7, 9, 11. What will be the next? It's 13. So what are we going to do with that? We need to add it to 27 to get the next term of the given sequence, and that gives you actually 40. So the next term in that sequence is actually 40. Let's have another sequence. Predict the next term in this sequence. We have 2, 7, 24, 59, 118, and 207. So using the same technique, getting the differences between terms, we have between 2 and 7, that's actually 5. Between 7 and 24, that's actually 17. Between 24 and 59, that's actually 35. Between 59 and 118, that's the difference is actually 59. Between 118 and 207, that's actually 89. So can you actually see the pattern and these first differences? So continuing the process, we get also the difference between these terms in the second sequence form. We have 5 and 7. The difference is actually 12. Between 17 and 35, that's actually 18. Between 35 and 59, that's actually 24. And between 59 and 89, that's actually 30. Okay, so now can you see a pattern on this second difference? We have 12, 18, 24, and 30. Looking into their differences or difference between two terms, we have 12 and 18. The difference is 6. 18 and 24 is also 6. And then we have 24 and 30. It's also 6. So continuing this pattern and these third differences, by adding 6 to 30, we get 36. And then adding 36 to 89, I'm sorry, that will give you 125. And adding 125 to 207, it gives you 332. So this is how to solve this problem, getting the next term of this sequence by getting the differences between terms. Maybe you have other technique or other formula or strategy to solve this. You can actually present it during our synchronous session. It's time to check your understanding. So you try this problem, you predict the next term in the sequence. You may pause this video and try to answer this sequence. What is the next term in this sequence? So let us now check your answer. So using the same strategy or technique, getting the differences between terms, we have between 1 and 7, that's actually 6. Between 7 and 17, that gives you 10. And then the difference between 17 and 31, it's actually 14. Between 31 and 49, that gives you 18. And then between 49 and 71, that the difference is actually 22. And then looking into the differences between terms of the first differences, we call this the first difference. Okay, so getting the difference also between terms in here, we have actually a constant 4, as you can see here, or recognize that the difference between terms is actually the constant 4. So adding 4 to 22, we get we get 26, and adding 26 to 71, we get 97. Therefore, the next term in the sequence is 97. Did you get it right? So do you have the same answer? Congratulations. Let's solve this problem. Assume the pattern shown by the square tiles in the following figures continues. We have to answer how many tiles are there in the 8th figure of the sequence, which figure will consist of exactly 320 tiles, and then what is the nth term formula for the number of tiles in the nth figure of the sequence. You can answer this by continue drawing the tiles using a graph paper, or you can also solve this problem by counting the number of tiles in the first 4 figures. In the first term or first figure, we have 2 tiles. In the second, we have 5. In the third, we have actually 8. And in the fourth, we have actually 11 tiles. Okay, so let's determine or discover the pattern in these numbers. We have a difference of 3 between 2 and 5. Between 5 and 8, there's a difference of 3. Then between 8 and 11, there's a difference of 3. Okay, so we already have the fourth term, that's 11. You can continue by adding 3 here until you get the 8th term. So that's one possible way of answering this problem. Okay, and then another one is you can actually look at how the figures here are drawn. Okay, so starting with the second figure here, we have look at this number of tiles at the middle. Okay, so we have 3 here, one at the top and one at the actually bottom. And then if you go to the third figure, there are 4 here, 4 is vertical, 4 tiles in this vertical line here, and then there are 2 here on top, and about in the other side is also 2. And then if we proceed to the next one, that becomes 5, and then the sides are composed of 3 tiles here, below it and above it. Okay, so I think that's one actually one figure or one pattern that we can actually see from the figure, and we can actually write that into equations or expression. That is, let's say this is actually n, that's actually 3, and then isn't it this is 1. Okay, so we subtract 2 to the given number n, let's say 3. So that's actually n minus 2. And then since there are 2, because we add from the top and from the bottom side portion of the figure, that will be multiplied by 2. And I think this is an expression, or maybe the nth formula for this figure, if you actually use that pattern or you recognize that pattern. Okay, so let's see here. Let's say, for example, this is 4, so n is 4. Then you subtract 2 to that, then multiply by 2, then you add to 4, you will get actually 8. Okay, or you can simplify this also, this figure, and that's equal to n plus, we have 2 times n is actually 2n, and then we have 2 times negative 2, that will be negative 4. Simplifying that, that gives you 3n minus 4, but we have to start here, n is equal to, or n, it should be greater than or equal to 2. We start with 2 as an n, and you will get, if you start with 2, 3 times 2 minus 6, 4 is actually 2. 3 times 3 is 9 minus 4, get 5. 3 times 4, 12 minus 4, get 8. And then you have 3 times 5 is 15 minus 4, you get 11. So that's one. Okay, so that's one formula for this sequence. So in this figure, we can also recognize or discover this pattern. Okay, so starting with the second figure here, look at the middle tile, number of tiles at the middle. There's 1, and above it there's 2, and below it there's 2 also. With the third figure, we have 2 at the middle and 3 above it and 3 below it. And then you have also the next one, we have 3 here, and then you have 4 above it and 4 below it. Okay, so if you can actually recognize that pattern or sequence, or how the tiles are being arranged here, you can actually write it into symbols, like for example starting with our n here, which is actually 1. Okay, let's say that's actually n. So we have, or you can actually have this as your n, the number of tiles. Okay, add on top of it. So we have here 2. Okay, let's say 2 is our n, and then there are actually that is actually being written twice or drawn twice. Okay, so you multiply 2 to that, because that means the number of tiles above and below. Okay, and then at the middle we have also we have to add to that number of tiles n minus 1. Okay, so n here represents the number of tiles above it, just like here we have 3 here, and then on the middle is we subtract 1 to that, so this is twice. Okay, so that's 2 n here, and then look at this, there's 4, and then the middle there's 3, so we subtract 1. So that's the representation of that system or process, okay, or a figure there. Okay, and then you can simplify this as to 3n minus 1. Okay, so for all n that's actually greater than or equal to, we may start with 1. Okay, so n is equal to 1. So if n is equal to 1, we have 3 times 1 minus 1 gives you 2. So here, if you count the number of tiles, there's actually 2 tiles. For the second figure, if n is equal to 2, that gives you 5. So there's actually 5 here. And then we have here, if n is equal to 3, that gives you 8. And then here we have 11. So if we're going to answer letter A, if n is equal to 8, so how many tiles there will be in the sequence? So substituting in this formula here, where n is equal to 8, we have 3 times 8, okay, minus 1, it gives you 23. So there are 23 tiles in the 8th figure. How about this problem here, letter B, number 2 question, which figure will consist of exactly 320 tiles? So using this formula here, we have to equate 320 to 3n minus 1, and then we're going to solve for n. Okay, so by substitution, by transposing negative 1 to the other side, it gives you 321 is equal to 3n. Then dividing both sides by 3, you get n is equal to 107. So the 320 tiles is the 107th figure. Okay, And then for letter C, what's the end formula? We just actually did it a while ago. It's 3n minus 1. So that's the end formula if you get the number of tiles for any given number of n. Okay, so that's how to solve a problem given figures. Okay, so you have to try this problem. So please try to answer this problem. Assume that the pattern shown by the square tiles in the following figure continues. How many tiles are there in the 10th figure of the sequence? Which figure will consist of exactly 419 tiles? And what is the nth term formula for the number of tiles in the nth figure of the sequence? So looking at this figure, so how the tiles are being formed, okay, so you may actually start with the second figure here, a sub 2. So you have 2, for example, a square here, which is a 2 by 2, and then we have added one square on top of it. Okay, and the third figure, you have a 3 by 3 square here, so that's 9. Then you add 2, that's actually 1 less than the given dimension of the square below it. Okay, and then for example, we have the a sub 4, we have 4 by 4, that's 16, and we add 1 less than 4, that's actually 3 here. And then same with the 5 by 5, that's 25, then you add 4 on top of it, so we get 29. So I think that's actually the process, the pattern in this figure, and we can actually represent that into symbols. That is, if we let n here equals 2, so that's a square, 2 by 2, you square that, that gives you 4, isn't it? And that can be represented in symbols as, if 2 is actually denoted by n, we have n squared. Okay, and then the one on top of it is we subtract 1 to the given n, and that can be represented as n minus 1. So I think that's actually the formula for getting the number of terms or number of tiles in the given figure and figure. So that's actually the formula for letter C. Then going back to letter A, we're going to get the 10th figure. We can actually just substitute that to the given formula here, or to the computed formula. Okay, so we have actually 10 squared plus we have 10 minus 1. So 10 squared is 100, and 10 minus 1 is 9. So the 10th figure is consisting of 109 tiles. So in the 10th figure, there are 109 tiles. And then we can now have letter B. So which figure will consist of exactly 419 tiles? So we have to equate this equation, okay, into 419 and solve for the value of n, and that is 419 is equal to n squared plus n minus 1. So it's already a quadratic equation. Okay, quadratic equation. So we have to equate that to 0. So by transposing 419 to the other side, it gives you n squared, okay, plus n, so that will be negative 420. Okay, so in solving quadratic equation, you can use quadratic formula or factoring. So in this case, we use factoring. We can factor this trinomial here, and that is equal to n plus 21 multiplied by another binomial, n minus 20. So solving for n here in the binomial factors, we get n is equal to negative 21, and the other value of n is equal to 20. So since we're looking for the nth figure, the value of n should be positive. So instead of using negative 21, we need to use the other value of n, which is 20. So the figure with 419 tiles is actually the 20th figure. So that's the solution to this problem. I hope you have the same answer to all the questions in here. Okay, so thank you. May I introduce to you a puzzle, the Ken puzzle, which is somewhat similar to Sudoku, but there's a big difference, no? So the numbers you use in a Ken puzzle depend on the size of the grid you choose. If you have 3 by 3 square or grid, you need to just use the numbers 1, 2, and 3. If you have a 4 by 4 square, you just need to use 1 to 4. And if you have 5 by 5 grid or square, you need to just use the numbers 1 to 5. And this pattern goes on or so on. Okay, the numbers in its heavily outlined set of squares called the cages must combine in order to produce the target number in the top corner using the mathematical operation indicated, that can be addition, subtraction, multiplication, or division. And here's how you play. Use each number only once per row, once per column. Cages with just one square should be filled in with the target number in the top corner. And a number can be repeated within a cage as long as it is not in the same row or in the same column. So that's how to actually play or actually do the Ken puzzle. Let us answer these Ken puzzles. So let's start with this 3 by 3 here. So as you can see, we have a cage here wherein there is only one number. So you may start with that. So this is 2. So you may actually write 2 here. And then here is actually 1. Also remember that if this is a 3 by 3, we can only use the numbers 1, 2, 3. Okay, and then next one is we need to actually do this cage here or this one here, and think of two numbers where when you subtract, the answer will be 2. So that gives that's actually 1 and 3. But where are you going to write 1? Is it here or here? So you can write either here or in this cell here. So we can actually write 1 here and then 3 here, or we can have 3 1, but I choose 1 3. Okay, so 1 is already here. So we have also 1 2 1 here in this row. We need to actually have 3 here, and in this vertical line here, we have a remaining 2 to complete the numbers 1 2 3. Okay, so if you subtract 3 and 2, the answer will be actually 1. So that's actually correct. So if this is 2 and this is 3 in this vertical line here, we need to write 1 here. That's the remaining number that we need to have, because that's one criteria for a Ken puzzle. We have to make sure that in its row or in its column, okay, we need to actually have the numbers written or used only once. Okay, once only. And then we have your 2 1, and then we need to have 3, and then in this case we need to add these 3 numbers here, and we get 6. So you have to write 2 here so that the answer will be 6, and you check also whether its number is present in its row, in its column, and it's only written once, and I think that's correct. So that's how to actually solve Ken puzzle. So let's try about this 4 by 4. Okay, so we need to actually use 1 2 3 4 and make sure that they are actually used only once in each column or in each row, and we need to actually satisfy the conditions in its cage or cage, okay, using the fundamental operations. So we may actually start with this cage here or anywhere you want. So I have to start with 2 here. We need to divide 2 numbers and the answer will be 2. Okay, so divide 2 numbers and the answer is 2. That will be 2 and 4. But what you're going to write here, is it 2 or 4? So you have to decide, no? And then you have to try 4 and 2. Then we may also have this subtract 2 numbers and the answer will be actually 1. So that's actually from 1 to 4. That's actually 1 or 2 or 3 and 4. Okay, 3 and 4, or it can be 2 and 3. So we already used 4 here, so we can actually use 2 and 3 here, and if you subtract that, that gives you actually 1. Okay, and then we have 4, 2, 3. So in this row, we need to have 1. And then what should be multiplied? Three numbers to be multiplied to get 4, because there are 3 cells or boxes in this cage. So the number will be 2 times 2 times 1. So 1, 2, 2. So that gives you actually 4. So we need to add to write, I'm sorry. Yeah, so it can be 2, 2, but actually we already use 2 here, so it cannot be, so we have to change that. So another number to be multiplied to get 4 is 1 times 4, okay, and then multiply to 1, that gives you 4 still. Okay, so we can change this to 4, and this should be 1. Yeah, that's actually correct. Okay, and then we have 2 here, 1 here, and 4, and then we need to actually have 3 in this box here to have completed the 4 numbers in this row. And then using this cage here, what should be subtracted to 3, okay, from 3 to get 2. So that's, I think, 1. Okay, and then in this column you can actually work, this should be actually 4. Yes, and then what we're going to add to get actually 8 here, to in this cage here, we can actually have 3, 1 and 3. So 1 is already here, so that's why we need to write 3 here, and then here it will be 1. So 3 plus 1 plus 4, that gives you 8. So that's already correct. And then in here you can actually start, this should be the start, okay, because this is just one cell in a cage, or one box in a cage, that will be 2. And in here you need to have 1, 4, 2, so we need to have 3 here. Then remember, here we have 1, 4, this should be 2. Yes, and then here 3, 1, 2, this should be actually 4. So check whether if you add these 3 numbers here, it gives you 9. We have 4 plus 2, that's 7. I have 6, I'm sorry, 6 plus 3, that gives you 9. So I think we already satisfied all the conditions in all the cells or cages, in all the cages. So I think we're solved this puzzle with 4 by 4. So I hope you learned from this. Okay, it's time for you to shine. So please try this can puzzle. So you may pause this video and try to answer this. Okay, so we have the answers. Okay, 1, and then we have 3 there, and then there should be 1, and then 2. Okay, we have 3 and 1, and then, okay, so that's the answer. And how about in the 4 by 4 can puzzle? We have 3, 2. Okay, maybe you have a different answer but still correct. Okay, this may not be the only correct answer in this puzzle. Okay, maybe you have another table, but this is how I actually solve it. So this is actually maybe one of the solutions. Okay, so congratulations for those who tried, and also for those who actually get the correct answer. May I introduce to you another type of puzzle, the rebus puzzle. So what is a rebus puzzle? A rebus is a puzzle device that combines the use of illustrated pictures with individual letters to depict words or phrases. Rebus puzzles, also known as picture puzzles or picture riddles, use images or words to convey a phrase or message, typically a common idiom or expression. The following word pictures or picture puzzles are pictograms that include a hidden word or a common phrase. Your task is to decipher the rebus puzzles. Let us start with this picture. So what do you mean by this? The answer is ready for anything. So are you ready for anything or for everything? So this one is ready for anything because the letter is red. So ready for anything. There are the word anything here is actually written four times. So we have the word for here. Okay, so did you get it? So that's one example of a rebus puzzle. How about this? Maybe this is the one of the most familiar okay phrase to most of us, or maybe we encounter this. So what do we by this? Broken promise. How about this one? We have no one to blame. Next, this one is all about, or it means first aid. How fast can you solve this tricky rebus puzzle? Make sure to take note of the placement of the words. So what do you think is this? It means travel overseas. How about this? The answer is not try to stand. If that's what you thought, keep guessing. The answer is try to understand. Okay, try to is actually under, that's the fraction bar stand. So try to understand. About this one, we'll throw in one of the easier or easiest robust puzzle to give you a brain arrest. So you actually use the color of this word. We call it greenhouse. So are familiar with what we call greenhouse effect? So we have greenhouse here. And then how about this? Notice the shape of this robust puzzle to help you solve it. The answer is, or this picture means street corner. Okay, street corner. And then how about this one? Maybe this is so important to us. Okay, as a person to have a peaceful or a more relaxed life, we need to forgive and forget. Yes. And then how about this one? Look at how the letters are actually written. So it implies there is actually a growing economy. And this when it means this is actually so important. Maybe we can define a friend. A friend in need is actually a friend indeed. Yes, a friend in need, because the word a friend here is actually at the middle of the word need, as you can see. And then how about this one? We have the numbers 1 to 40, and then we have the word life. There is actually a famous line or expression, life begins at 40. And how about this? We can say that if you're happy, they say that you are at cloud 9. Okay, so you are on cloud 9 if you are so happy. And then how about this one? So falling in love with someone. Falling in love, okay? And then how about this one? You meet, or this happens only, or it occurs only once in a blue moon. Okay? And then how about this? This is so important. Maybe during this pandemic, we actually feel this missing someone, missing you. Okay, because in this alphabet there is no letter U, so it's missing you. Okay, did you miss someone? Did you miss something? Okay, so that's actually a robust puzzle. And that's all for this video. I hope you learned something from it. Okay, and see you in our synchronous meeting. Stay safe. Bye.